Hello, good morning, my dear friends. Welcome back to the video lecture. So, we are discussing our analytical chemistry of paper CHA393, that is CBOP 3. CBOP 3. In that, we have choice the B section, and again, this is the section first, that is analytical methods of food analysis. Our next chapter is the ash analysis. So last time we have covered the moisture and total solid analysis. Okay, so the different aspects of moisture and total solid analysis we have already seen, covered in the previous videos. Today we will learn about this ash analysis. So first of all, let us see what is meant by ash. So ash is what, when we burn any material, then the remaining residue of that material is known as ash. The technical definition of ash is the inorganic residue remaining after ignition or complete oxidation of organic matter. Complete oxidation means there should not be any substance remain to oxidize. Okay, so therefore all these substances are converted to either oxides, sulfates, phosphates, nitrides, okay, etc. So this technique is called as, or this material is called as ash. So ash of any material, ash of any substance is nothing but the substance or the material or the inorganic residue remaining after ignition. After ignition means after burning, what is remain left, that material is nothing but the ash material. Okay, and this ash material is important in foodstuffs or in food samples. So that's why this ash analysis is important for the food samples point of view. Now let us see the two technical definitions of dry ashing and wet ashing. Dry ashing and wet ashing are the two fundamental or basic types or methods for the determination of ash from any material or any sample. Okay, so dry means no use of any liquid material. Okay, literal meaning. So dry ashing is concerned with the use of muffled furnace. So what is muffled furnace? Muffled furnace is related to a special type of equipment or furnace which is used for the high temperature ignition, high temperature drying, that is aimed to be high temperature reactions or high temperature drying, and that is operating in the range of 500 to 600 degrees Celsius. So such a high temperature is used, we can use, okay, in the muffled furnace. And when we are using muffled furnace in this temperature range, then that method of drying or that method of ashing is called as dry ashing. Okay, then the second one is called as wet ashing. Wet ashing, in the sense we are using here some liquid components for the ashing purpose. For the ash determination, we are using some liquid components such as oxidizing organic substances by the use of some acids and oxidizing agents. This method, wet ashing, is generally used when our purpose is to oxidize mainly organic substances present in the food sample. Then such wet ashing is generally followed by the industries or followed by the researchers in the field of food analysis. Okay, so different types of acids, generally nitrous acids, sulfuric acids, or hydrochloric acids, or some oxidizing reagents are generally used for the wet ashing purposes. Okay, and these are oxidizing the all organic matter into the oxides of that compounds. Suppose if our sample is containing carbon, then the carbon is oxidized to carbon dioxides. If our compound is containing nitrogen derivative, then that nitrogen is converted to oxides of nitrogen, etc. Okay, so these are the two main topics, main definitions of this dry ashing and wet ashing in this chapter. In previous text, in due course, we will see in detail how to do this wet ashing and dry ashing. Now, importance. What is importance of ashing? What is importance of ash determination? So, this ash analysis is very important from the nutritional point of view. Okay, so when we are our topic is food analysis, so that's why it is related directly to the health. Okay, health of human being, health of organisms, etc. So that's why if we have to determine, we have to use our food product at the national or international level marketing, then we should give information related to the ash analysis when our substance or our food sample is ignited, incinerated at a high temperature, then the remaining material, that is called as ash. So what is that analysis? What type of elemental elements are present or can be found in that ash, that is determined in ash analysis. So that's why it is having nutritional value, and such information generally printed on the label which is stick on the food samples. Okay, then general ash contents of food materials or food products is vary according to the food per food. Okay, so some food samples are having low ash content, some food samples are having high ash content. Generally the high fat content, generally meat, fish, then chickens. Okay, one more example like different milk products, all these are having high fat content, and hence such compounds or such food samples are having high ash content also. Okay, so that's why the ash content is varying as per the food material, and they are not more than 5%. On an average, they are not more than 5% in most of the food samples. Then our target is we have to do ash analysis. Okay, so for that we have to prepare the sample preparation. So generally 2 to 10 gram of sample is generally used for that ash analysis, and this weight of sample is taken in a crucible, and that crucible is then incinerated or ignited using different techniques. Okay, so this is the this is the sample size for the ash determination. Then methods of ashing. The first, there are mainly two methods that I already discussed, that is dry ashing and wet ashing. Out of these, the first one is dry ashing. So dry ashing is nothing but what? Use of muffled furnace. So in dry ashing we are using muffled furnace at high temperature range, in the range of 500 to 600 degrees Celsius. Okay, in this case different types of crucibles we can use when we have to ignite our food sample in which is taken in a crucible, and that crucible is generally they are kept in a muffled furnace, okay, for a particular period of time, and when muffled furnace is put on, then that heat generated in that muffled furnace in presence of air, okay, it converts all the organic material into oxides form. Okay, so that's why the remaining part we called it as a ash, that can be utilized for the analysis purpose. Okay, so different crucibles can be used here. The first one is quartz crucible. So quartz crucible, they are generally resistant to acids and halogens. They are resistant to acids and halogens, but they are not resistant to alkalis or bases. Then porcelain crucible. Porcelain crucibles are general use. We use porcelain crucibles in our college laboratory also, in university laboratory also, or research laboratory also. Okay, they are of general size and use. Okay, but they may get crack if the temperature change is rapid. Means we are igniting that food sample in the crucible, porcelain crucible, in the muffled furnace, and if temperature variation, that is sudden increase or sudden change, sudden decrease in the temperature, it results into the cracking of that porcelain crucible. So all this information is related to the different types of crucible that we can use in the muffled furnace for ash analysis. Then the third one is given is steel crucible, stainless steel crucible. The utensils that we are using in our kitchen, household kitchens, that are called as stainless steel utensils, and the same material is used for preparation of steel crucible, and it is resistant to both acids and alkalis. Okay, so that's why it is very much useful. And the last one is quartz fiber crucible. Okay, so they are widely used because they are non-breakable. Okay, and the temperature range is very high, so we can use them up to about 1000 degrees Celsius. Such a high temperature can be applied to this quartz fiber crucible. Okay, now the next point is procedure. So what is the procedure, actual procedure for the dry ashing ash analysis? Dry ashing ash analysis. Okay, so here we have to choose first of all that which crucible we are going to use. Okay, from this we have to choose one of them. Okay, then take 5 to 10. Then take here 5 to 10 is the sample size is generally taken, and general size is 2 to 10 depending on the purpose. The sample size may get vary. Sorry. So 5 to 10 gram sample is generally taken in a crucible, pre-weighed crucible, let us say pre-weighed crucible. So the crucible is generally pre-weighed, tiered crucible we can say generally. Okay, and it is then taken in a it is kept in a cool muffled furnace, which is off before keeping this crucible into the muffled furnace. Muffled furnace is just like our oven, hot air oven that we are using in our laboratory. Okay, but you can search it on internet that what are the shape, size and images of this muffled furnace. Okay, so it is kept in a cool muffled furnace. Then ignite that sample taken in crucible, which is kept in a cool muffled furnace for about 12 to 8 hours or overnight at about 500 degrees Celsius. So such temperature range is given for that muffled furnace. So within 12 to 18 hours, within 12 to 18 hours, most of the about 99% of the organic material is get ignited and it is get converted into the inorganic residue, and that is called as ash. Then after ignition or incineration taken place, the muffled furnace allowed to cool at about 200 to 250 degrees Celsius. Okay, then allowed to cool. Then after cooling, use pair of tongues, then hand gloves, then eye protection equipments. Okay, they are generally used because this range of temperature is very high. Okay, then transfer this material after incineration, after ignition, to the desiccator, which is having a cover and a desiccant material. Okay, generally fused calcium chloride is generally used as a desiccant material, or desiccated material is generally used in desiccator. Okay, then after having this, we can weigh that crucible. After complete cooling, we can weigh that crucible, the tare weight of that crucible that we have already taken before keeping them in a muffled furnace, then percent ash analysis can be done. Okay, and this is the formula, that is weight after ashing, weight of that sample after ashing minus stir weight of crucible. Okay, so weight after ashing of that crucible minus stir weight of crucible divided by original sample weight, that this is the weight, original sample weight, this is original sample weight, into dry matter coefficient, and total this is multiplied by the 100 degrees, 100. This is percent ash analysis, can be calculated by using this formula. Weight of the crucible after ashing minus stir weight of crucible, okay, divided by original sample weight into dry matter coefficient and into 100. This gives you the information about percent ash analysis by dry ashing method. Okay, so this is all about the today's lecture, and the remaining part, that is second method, wet ashing, and the microwave assisted dry ashing and wet ashing methods, that we will see in the next lecture. Okay, thank you for seeing this video. Have a nice day.